Okay, today is class number 19. We are covering an important concept known as inverse functions. This concept is so important, we're doing it twice. So we're going to come back on Monday and talk some more about inverse functions. Also note on Monday what's happening. Project number 2 is due. Hopefully we've made a lot of progress on project 2. If you haven't, then this is what you're going to be spending your weekend on. Project 2 is all about transformations. Okay, so that's going to be due first thing on Monday. I think there's a lateness penalty. So I don't remember. We have to look in the syllabus. Do I take projects late? I teach so many classes. I don't know what I do. Look in the syllabus, but much better not to be late than to be late. Okay. I think the syllabus might say I don't take them late. So 1 p.m. on Monday is what we're looking for there. Continuing to look ahead into next week. Once we finish Monday's topic, that's the last new material before the test. Wednesday coming up next week is our review day for the test, which is happening on Friday, 1 week from today. That test is going to cover the material from classes 11 through 20. That is to say everything since the first test, 11 through Monday's class, right? Hopefully you have some time this weekend to get a jump start on studying for the test 1 week from now. And as you know, at the end of this packet are some sample test problems that you can practice on. And there are also videos of somebody solving those problems on YouTube. Okay, any questions on the schedule? Okay, so let's take a look. We're going to go past page 82. Hopefully we made some good progress there. And we're going to look at the demo on page 83. Number 1, let h equal f of t equals 6 plus 2t. So f of t is our function notation way, and we're just going to call the whole thing h, just like a y equals, but it'll be h equals. That formula is going to be the height, that's the h, of corn seedlings in inches t days after they are planted. T days after they are planted, that formula gives you the height in inches of this thing that starts at seed. So we'll make a table of values for that function. If we plug 0 in, we're looking for, I'm just going to write this one time here, but f of 0 is how much? Plugging 0 there, so 2 times 0, that's a 6, is good. And then we plug 1 in for the t, 6 plus 2 times 1, that's 8. And I think the next ones are 10 and 12. Yep. Okay, and then part A says write ordered pairs t comma h for the function described up above. So here we're just copying the first ordered pair is what comma what? 0 comma 6. That's it. So go ahead and fill in the other 3 based on the table. Okay, so what we just saw was a way to input the time and output what? The height, right? We input a bunch of times and we got a bunch of heights as the output. In part B, it says, suppose I want to know how many days it would take, oopsies, how many days it would take for the height of the seedling to reach a height of h inches. So in this case, what's the input? It's the height. I want to know how long it's going to take for an input of the height. So if you give me the height, I'd like to know how long it took to get there. So for example, if you tell me the seedling is 10 inches tall, what's the output? 2. It took 2 days to get to that height, right? It's the same problem, but thought of in reverse, right? The input and output need to swap roles here. So what we're going to do, instead of having a formula, which I'll recopy here, instead of the formula h equals 6 plus 2t, what letter would I really like by itself? I'd really like the t by itself. I really wanted to say t equals. So let's solve this equation for t. What needs to move first, the 6 or the 2? 6. Subtract 6 from both sides. And then divide both sides by 2. Can I cancel the 6 and the 2? 3 and 1, is that all right? So h minus 3. That's really okay with everybody? Yeah, I mean, that 2 is not just under the 6. What else is the 2 under? H. And if we just cross off the 2, it's all of a sudden no longer under the H. So we cannot do that. So we'll leave it just as it is. H minus 6 over 2. Okay, and then reading again, in this equation, H is the input and T is the output. So that means that if I'm thinking of this like as XY, it's H comma T. Agree? Plug in an H, you get out the answer of T. Okay, so we've interchanged the roles of the variables. T and H have swapped places. We're going to create a new table for this brand new function. The function that's written up here, T equals H minus 6 over 2, is there. The only thing in the middle is just a brand new function. We're calling it the G function. That's not super important, but G of H is now the input. Okay, let's fill in. If we plug in 6 for H, 6 minus 6 is nothing divided by 2 is nothing. So I'll just put this here. G of 6 is 6 minus 6 over 2, which is 0 over 2, which is 0. Okay, if we plug 8 in, 8 minus 6 on the top, 2 divided by the 2 is 1. See if you can fill in the other 2 blanks. Plug 10 in for H, and then plug 12 in for H. What do we get for 10? 2, and for 12, 3. And this other table right here is just copied from the one that we have up above. And what do we notice about these 2 tables? Just flipped, right? Originally it was a 0 and a 6, and now it's a 6 and a 0. It was 1, 8, now it's 8, 1. And we'll see it again here if we just write down ordered pairs of the form H comma T from that first table. We said 6, 0, and the next one is 8, 1. And then 10, 2, and 12, 3. And how do those coordinates compare to the ones in purple? They're just reversed, right? Exactly the same numbers, just reversed. So for example, 12, 3 has become, 3, 12 has become 12, 3. You buy it? The roles have just reversed. Okay, so these 2 functions, I'm skipping down here to number 2. So we called the 2 functions f of x equals 6 plus x. It was a 6 plus t. And g of x equals x minus 6 over 2. That was a t minus 6 over 2. We call them inverse functions. Inverse functions. That's the topic for today and next class. The fact that g is the inverse of f, this is notation, is expressed by renaming g as f. It looks like f to the power of minus 1, but nobody wants to read that as f to the minus 1. You read it as f inverse. And so here's our better way of saying it. We've seen f of x is 6 plus 2x, and now brand new f inverse of x is x minus 6 over 2. And these 2 functions are opposites. They undo each other. And that might not be clear just looking at the information up above, but let's make it really, really clear here. If I picked, for example, f of, let's do 7, just making up a number. We have not done 7. This 7 is an x value or a time value. F of 7, using the first formula. 6 plus 2 times 7, I heard a 20. Is that right? Okay. F is this function which takes the number 7 and sends it to the 20, right? F inverse, brand new notation. Go ahead and write this here. And what I'm going to do is put a number in here. Anybody know what number we're putting in? It's a 20. Putting a 20 in there. Let's see what happens. This formula is x minus 6 over 2. So 20 minus 6 over 2. 14 over 2 is 7. So f takes the number 7, sends it out to 20. F inverse takes the number 20, brings it right back to 7, which totally makes sense if you remember that all we were doing was swapping the input and the output. Input was 7, output was 20. Well, if we just swap them, then the new input is 20 and the new output is 7, right? And so these two functions, like I said, they undo each other. F takes the number 7 someplace. I don't even care where it goes, but F inverse takes it right back to 7. Right? The 20 is somewhat irrelevant in this idea of inverse. All we know is that 7 is going to go out into the ether and come back, and it's going to become a 7 again. Right? It's temporarily a 20, but it comes right back to 7. And so there wasn't anything special about the number 7. We could have picked 8 or -42 or pi. It would all end up coming right back to whatever your starting value is. And we're going to prove that mathematically first thing in the activity on the next page. But one other thing I can say about this, just to really convince us that, that these two functions are really like hardcore inverses of each other. In plain English, what's the first thing we do with our number x here in the original? We're doubling it, right? Multiply x by 2. That's the first thing. So first we double, and then we add 6. Yes? In the other direction, first we subtract 6. First we subtract 6, and then we divide by 2. Do you see it's exactly the same stuff, but reversed and in the opposite order? Which is this thing with the socks and the shoes, right? Like when, like in the morning, you put on your socks, you put on your shoes. When you go home, you do the inverse, but you got to do it in the opposite order, right? First you take off your shoes, then you take off your socks. So here, first we doubled, then we added 6. We have to undo in the opposite order. First you take away that 6, then you cut it in half. Okay, so on the next page is the definition of inverse. It says that two functions are inverses. Two functions are inverses if this is true. We got two equations here. First one says f of f inverse of x equals x. A lot of symbols, but I want it to make sense. What's the input letter? The input letter, the variable that is buried as far inside of this as possible, is the x. That guy right there. That's the input, right? And we put x all the way in. And first we apply f to that number, and we get a new number out. It's like 7 becoming 20. And then when we do f inverse on the 20, we get right back to 7. Whatever we put in, all the way in, goes someplace, but then it comes right back to x. If you start with an x, you end with an x. And this is going to be the way that we prove that two functions are inverses. Let's try it on the next page here. So I know this is part of the activities. We're going to do one of these guys together, and then you'll do the rest with your neighbors. So number 1, starting with the same two functions, 6 plus 2x and x minus 6 over 2. We're not going to do part A. We're going to do part B right now. Let's try this. Okay, the first symbol, f circle f inverse. Remember that means f of f inverse of x. So that's written on the right-hand side of the equation. Which are we doing first, the f or the f inverse? We're doing f inverse first, which means we are copying f. So copy and give yourself some space there. And what we are supposed to put in here is whatever was in the big parentheses originally. That's an f inverse, right? F inverse of x is just a formula. It's given at the top of the page. So what are we putting in here? X minus 6 over 2. So that's the first step. Everybody see it? The outside f, the outside function f is just copied, waiting. The inside function f inverse just got replaced with specifically the formula for f inverse. Okay, this is the hard part. We are going to apply f to this complicated thing that's highlighted in yellow. F is a formula which takes whatever is in the parentheses, doubles it, and adds 6, right? That's what we discovered. So whatever is in the parentheses, we just have to follow this formula here, 6 plus 2 times whatever was in the parentheses. Yes? So I'm going to write that as a basic shell, then we'll fill in. 6 plus 2 times, I'll put some parentheses there. 6 plus 2 times whatever was in the parentheses. So what was in the parentheses? It's the stuff that was highlighted in yellow. X minus 6 over 2 is it. The algebra here is going to be pretty easy, and I hope it's going to be somewhat satisfying at the end. But that's the hardest step right there. Are there questions on what we just did? So again, we know that f is this function which takes whatever's in the parentheses and puts a 6 plus 2 times it, whatever it is, gets shoved out there at the end. 6 plus 2 times it, whatever is in the parentheses. That f of stuff reminds me of this f of x. So whatever was in the parentheses, actually we'll circle this. This guy here, this part right there. Okay, and now we're going to clean this thing up and hopefully good things happen. 6 plus, you are welcome to distribute that too. You could do a 2x minus 12. Some people are going to write this. Don't write this. 2x minus 12 over 4. What did they do? They multiplied top and bottom by 2, right? Okay. It's not. That 2 is really 2 over 1. If you're putting something on the bottom, it's a 1. It is not a 2. So if you wanted to, you could do this. I still don't think you should copy it. But you could just distribute the 2 on top and leave the bottom as it is. But much better, Trevor. Cancel the 2's. It's multiplication. 2 on the top, 2 on the bottom. Don't distribute there. Equals. Okay, so I'm just going to write down what's left. 6 plus, I'll put the x minus 6 in parentheses, although I don't think it's needed here. And then what happens? Yeah, the 6's cancel, right? Plus 6 minus 6. Let me just get x. And that's really fantastic because what was the thing that we started off with on the very inside of this function, both functions, inside was x, right? Oh, man. Inside was x. And then we did all this algebra. And ultimately, at the end of the day, x. That's how we prove that one function is an inverse of another. We didn't just prove that 7, which goes to 20, ultimately comes back to 7. We proved that any x goes wherever it goes, but it comes back to x. Okay? Technically, this is only half of the proof, and on a test or a quiz, I might expect you to do both, and you're going to do part C right now. But what's the difference between part C and part B? Yeah, in part C, we're doing the inverse function on the outside, right? The order is different. And so what we just showed was like the example 7 goes to 20, comes back to 7, but technically we still need to show that 20 might go to 7 and then come back to 20, and that's what you're going to do there, okay? All right, so start off with part C there and then just continue on. You can skip part A and raise the flag if I can help.